Hi everyone, welcome to my channel. In this video, let us learn the chapter name Linear Programming. The complete concept will be explained in this video. So I want you to go through the video completely. The word linear means a degree of a variable whose power will always be 1. Programming is nothing but set of procedures that we are going to follow, set of constraints that we are going to analyze and find the feasible solution. This is nothing but linear programming. So in this chapter, we mainly concentrate on optimization of the solution. What is the meaning of optimization? Ultimately, everyone runs a life for profit. So here, a branch of mathematics which is called operational research, where we have this optimization concept which ultimately deals with the maximum profit with minimum cost. So that is our main motto in this chapter. Optimizing the problem is nothing but finding the maximum profit with minimum cost or minimum expenditure of the resources. So the process which you are going to do it here is nothing but linear programming problem. Now, we have a methodology, or we can say a formulation of the problem into mathematical statement. Once you have done a mathematical statement, then we are going to solve it to find its maximum profit with minimum expenditure. So let's understand the concept with an example. So before going to an example, let me introduce few terminologies. The terminology is nothing but objective function. So objective function is the key for us, where you are going to maximize or you are going to minimize the problem. Either it can be maximum the profit or minimum the loss. The equation which we write in terms of inequalities are called constraint. Constraints are nothing but conditions. X greater than or equal to 0, y greater than or equal to 0, these are nothing but non-negative constraint. The linear programming problem is one that is concerned with finding optimal value, that it can be maximum or minimum value of which function? Objective function. Objective function. It can have a non-negative constraint, as I said here, x greater than 0, y greater than or equal to 0. And we will come across equations or inequalities of linear form. You can see the variable power is 1. So it's a linear. We say inequality because it is less than or equal to, greater than or equal to. It has an inequality sign. So what is a general form of writing an objective function? The general form of writing an objective function is z is equal to ax plus by. What are a and b? They are constants, which has to be either maximized or minimized. This is called objective function. Z is equal to ax plus by. The previous problem which we had, where the coefficient of x, that is 250, and coefficient of y is 75. That was our objective function. Here the variable x and y are the decision variable. Why? Because the value of x and y is going to decide the profit or the loss of the objective function. As I mentioned earlier, constraints are nothing but the conditions or set of rules, which we can say, or restriction. These are nothing but constraints. So optimization problem, a problem which seeks to maximize or minimize a linear function subjected to certain conditions, is nothing but optimization problem. So now let us understand the first concept here. There are different methods of solving a linear programming problem, but for class 12, we have graphical method of solving a linear programming problem. It's a very simple concept. Now let us see. Based on the previous example, they have given the constraint 1, 2 and non-negative constraint. What are we trying to do it here? We are going to, it's a linear inequality, so obviously you will get a straight line. Graphical representation of a linear form is straight line. So we'll get one straight line, two straight lines. Then what are we going to do? We are going to find a feasible region. Feasible region. What is this feasible region? Every point of the region is a feasible solution. That means the region which you're going to find, you can see this a shaded portion. This is called feasible. I'll explain it in depth when we are solving problems. Feasible means these are the possible points which will help us to find the maximum or minimum solution for our objective function. Okay. So let's understand the exact method of solving a linear equation. Let me consider one example. Solve the following linear programming problem graphically. So this is nothing but objective function. Objective function. And what are these? These are the constraint. X plus y less than 50, first constraint. 3x plus y less than 90 is the second constraint. And these are nothing but non-negative constraint. So now what we have to do? We are going to express it graphically. So this is our equation. Actually this is not equation, it is an inequality. What we have to do first step? We will take it as equal to. That is our first step. So when I take this as x plus y equal to 50. Let me take a value for x, you get value for y. So what are the coordinates we have got? Okay, the same way 3x plus y less than or equal to 90. Repeat the same procedure. Find its coordinates. Now you can see that here the coordinate points, this we will come later. Let's have the graph. You can see that there is one straight line from the equation 3x plus y is equal to 90 and another equation which is x plus y is equal to 90. Since it's a linear equation, we have got a straight line and you can see that these two straight lines are intersecting at this point. Now, how to find this feasible solution or how to find this feasible region? Go back to the equation. So what is the equation given here? X plus y is less than or equal to 50. So we will go to this equation straight line. So this is an equation. This line value is less than. So less than means it should come downwards. Less than or equal to 50. What is the second line we have? The second line is 3x plus y less than or equal to 90. Again it is less than. So less than means downward. Again it goes like this. Now you can carefully see that intersection of both the lines is where we get feasible solution. So which region? You can check. This is also a region where we have only the line 3x plus y, but we don't have this line. So this is not our feasible region. Check this region. This is also bounded one, but again this has this line, but it doesn't have the second line. So this is not feasible region. Now this is again bounded, where here you can see both the lines are intersecting. That means both the lines are having a common value in this region. This region is called feasible region. Feasible region. Now how to find the solution? Take the coordinates. The coordinates here is C 0, 50, B 20, 30, and this representation A is 30, 0, and this is 0, 0. These are the corners because these are the feasible point for the objective function. So write it. What is our objective function in the given question? Z is equal to 4x plus y, and you are going to find its maximum value. So Z is equal to 4x plus y. Substitute the coordinate values in place of x and y. On substitution, 0, 120, 110, 50. The question says maximize. So maximum value. So what is the maximum value in this? When x is equal to 30, y is equal to 0. What is the objective function? The maximum value of the objective function is 120. Hence, the maximum value of the objective function is 120 at which point? 30, 0. If suppose the same question is asked and if it is less than, that means minimization problem. What is the difference? For maximization you have less than or equal to. For minimization you can have greater than, less than or less than. But always keep in mind, if minimization, which feasible solution you have got, right? After substitution, take the minimum value. If it is maximization problem, after substituting to the objective function, which is the maximum value, that will be the solution. That means when x is equal to 30, y is equal to 0, this objective function has maximum. It can be in terms of profit or it can be in terms of any other parameter. But it is maximum when x is equal to 30 and y is equal to 0. I hope this explanation you have understood. In the next video, I'll try to explain one problem. Thank you.